Hi guys, welcome back to my channel. Today I'm going to be introducing you to the idea of using theorems to support proofs. So it's a little bit complicated because there are some rules that we are going to learn, but the process of actually doing the proofs itself is not that tricky. So we're going to go through some background information to start off with, and then we're going to jump into doing some questions. So to start off with, we're going to have a look at some different parts of the circle. In particular for this video, we should already be aware of what the diameter of a circle is, what the radius of a circle is, and what the circumference of a circle is. Potentially some new terms to you would be the tangent. So a tangent is kind of like the slope at that instantaneous point or that particular point. Here we have a secant. So a secant is a chord that extends beyond the circle. Here we have a chord. So a chord is like a cut through the circle that does not extend past the circumference. And then an arc would just be a small proportion or a small portion of the circle. So now that we're sort of familiar with those parts, what we're going to do is we're going to have a look at some different rules that we can use to predict the angles of certain shapes within a circle. To start with, we're just going to have a look at these first two theorems. So some of these rules can be a little bit complicated in the way that their language is used. So I've tried to break this down for you to make it a little bit more simplified so that you can actually understand the theorems, so that you're able to use the theorems to find values of particular angles. So here our first rule, or our first circle theorem, is that the angle subtended at the center of a circle is twice the angle subtended at the circumference standing on the same arc. Yeah, a little crazy. So if I was to put that in English, what I would say instead would be, if I have a circle, right, and in the middle of the circle here, I've got two lines that are coming out. Now I'm going to make another angle here, right? So that's all I'm doing when I say subtending, is I'm making these angles. So the angle that's in here, the angle at the circumference, is going to be half the angle at the center, or the angle at the center is going to be double the one at the circumference. Okay, so the second circle theorem that we're going to look at is when we have angles in the same segment. So from before, if I was to, say, cut this circle here, so this here would be a segment of that circle. Now, the really cool thing about this rule is if I was to draw any sort of crisscrossy shape, right, because these two angles are in the same segment, that means that both of these angles are going to be the same. And it's the same thing if I was to cut across the bottom here. Because these are in the same segment, these angles are going to be the same as well. And it doesn't matter how symmetrical looking your shape actually is, because it's still in the same segment, and so therefore the angles will still be the same. So I'm going to call this, why don't we call this one the center and the circumference rule, and we'll call this one the crisscrossy rule because it makes a crisscrossy shape. So we're going to use our center and circumference rule and our crisscrossy rule in order to find unknown angles within a circle. Let's start off with three really simple examples here. So when we are going to write these proofs, or when we're going to write the reasons, we're writing the geometrical reason or the theorem or the idea for which we got the idea that the value of x is going to be equal to 30. Right? So it sounds a little bit strange, but really all we're doing is we're just writing down the proof or the theorem, and then once we've written down that proof or that theorem, that justifies the value x is equal to 30. So I'll show you what I mean here. So for this question here, all I'm going to do to answer it, right, is I'm going to write the theorem. So rather than writing theorem 1 or theorem 2 or theorem 3 or whatever, because there are a huge number of different theorems and not everybody uses the same notation, what we're going to do instead is we're going to use a little code. So the code that I'm going to use is going to be that crisscrossy looking code. So I'm just going to draw a circle with that crisscrossy shape in the middle. And then, because of the fact that these two angles here and here are in the same segment, it means that those two angles are going to be the same. And since this angle here is 30, it means that this angle here is also equal to 30 degrees. So that's all I need to write. So let's have a look at this second example. And again, we can kind of see, so we've got a crisscrossy shape that's going here. And that means that x and y are going to be the same values. I can also make that crisscrossy shape though with this shape in here, right? And again, because these two angles are in the same segment, that means that they're also the same value. So what that means is, since 25 and y are the same, and x and y are the same, that both x and y are equal to 25. So again, I'm going to write my supporting statement or my supporting argument. So my theorem, and I'm going to continue to call it the crisscrossy theorem. We're going to draw that diagram. And so we're going to write x is equal to y, which is equal to 25 degrees. Okay, last one here. So again, I'm sure you can see where this is going. The first thing I'm going to do is I'm going to write the particular piece of proof that I'm using. So I'm going to use this crisscrossy proof. So again, I'll just draw the little crisscrossy code. And again, because these two angles are in the same segment, that means they are the same. And so we're going to write x is equal to 32 degrees. Let's have a look at some slightly more complex examples now. So this example for G here, it doesn't look like any of the two theorems that we've gone through before, but it actually is, because the theorem that we spoke about first, right, if we have one on the circumference and one in the center, and we can make some sort of a shape there with it, this angle here is going to be half the angle at the center, or we could say that the angle at the center is going to be double the angle at the circumference. Now I can see that this point here is touching the circumference and it's 42 degrees, and this angle in here is in the middle. So I'm going to use this theorem to state that x is equal to 84, sorry. So again, when we do this, I'm going to write the theorem. So this is the circumference and center theorem. So when I do that, I'm going to draw a dot at the circumference, a dot at the center, and we're going to join those up like that. So because of this particular rule, that means that x is equal to 84 degrees. All right, let's have a look at example H here. Now, for example H, I can see that there are a couple of different things going on. First of all, I can see here that I've got an angle at the center and I've got an angle here at the circumference. So I can use that first rule to determine that y is going to be equal to 100 degrees. So again, I'm going to write my little code. So when I draw my circle, I'm going to draw an angle at the circumference, an angle at the center. And I know this angle at the center is going to be double the angle at the circumference. And so we can write y is equal to 100 degrees. Now, this angle here, if I was to draw this looks like a crisscrossy angle to me. And so for angle x, we can use that second theorem. Again, very professional term here, the crisscrossy theorem. So we can write that x is equal to 50 degrees. All right, last one here. Now here we have a semicircle, right? So if I was just going to pretend that this was a full circle, then this point here would still be at the center. So again, I'm going to use my center and circumference theorem, because this angle here that's at the circumference is equal to 28 degrees. The angle at the center is going to be double that. So we know that x is going to be equal to 56. So again, I'll just write my theorem. And in this case, it's going to be the center and circumference theorem. And using that theorem, we know that x is going to be equal to 56 degrees. All right, so those are just two theorems that we're going to be looking at. So we'll cover the rest of those theorems in class. So I just want you to sort of wrap your head around the idea that we're going to be using this information to determine particular angles. And it's not really a very algebraic process. It's not like we're just going to chuck this into a formula and get a solution. So we're going to have a look at a list of different theorems that we're going to use. If you wanted to get ahead of this and you want to get on top of this, then I would suggest having a look at chapter 19.2 in your textbooks. That's the red year 10 textbooks, the Maths Quest textbooks, and have a look at the list of different theorems, because there's about 6 different theorems that we're going to have a look at just for our first lesson. There's another 6 or so that we're going to look at for our second lesson of the week. And then there's about another, I think it's 3 that we're going to look at for the last lesson of the week. But really, it's the same process. We're just going to identify the correct theorem. And then using that theorem, we're going to state the value of unknown angles that are in a circle. All right, guys, I'm going to leave you to it. I'll see you in the next one.